In this tutorial, I'm going to use the Moivre's theorem to find all solutions to the equation z to the power 4 is equals to 16 and giving the answer in a polar form. The Moivre's theorem states that for any real number theta and an integer n, cosine of theta plus I sine of theta to the power n is equals to cosine of n theta plus I sine n theta. We can write the z there in polar form, and it will be z is equals to r multiplied by cosine theta plus I sine theta. So on the left hand side of the equation that we are having a z to the power 4. So if we raise that z that I have written in polar form to the power 4, it will give us z to the power 4 is equals to r multiplied by cosine of theta plus I sine theta to the power 4. And then we can take that r outside those square brackets so that we have r to the power 4 multiplied by cosine of theta plus I sine of theta to the power 4. Now looking at this part here, cosine of theta plus I sine theta to the power 4, we can now use the Moivre's theorem to rewrite that, and in this case we'll see that our n there is a 4 because it's raised to the power 4, and wherever we have the n in the Moivre's theorem above there, we put a 4, and then we'll get r to the power 4 multiplied by cosine of 4 theta plus I sine of 4 theta. So we now have that equation there, that the power 4 is equals to r to the power 4 multiplied by cosine of 4 theta plus I sine of 4 theta. On the right hand side of the equation that we are supposed to solve for the z to the power 4 equals to 16, we are having a real number 16 there. When we have a real number, we can write it as a complex number, but its imaginary part will be a 0. So 16 as a complex number will be 16 plus 0i. And we can then go on and write the 16 plus 0i in polar form. So the 16 plus 0i in polar form will be 16 multiplied by cosine of n times 2 pi plus I times n times 2 pi, where n is equal to 0, 1, 2, and so on. We are having so many n's there, 0, 1, 2, and so on, just because cosine and sine they are periodic. So it will be repeating itself after every of those integers after 2 pi. So it will be 2 pi, 4 pi, and so on. And that's why we have 16 there is equals to 16 multiplied by cosine of n2 pi plus I sine of n2 pi. But the equation that we want to solve is this one, z to the power 4 is equals to 16. So I will go on and number these equations, equation 1 and 2 respectively, and then look at those equations. We're having z to the power 4 and the other one is having a 16. But the equation we want to solve is z to the power 4 is equals to 16. So using equation 1 and 2, it will give us that those two, they are equal. So the z to the power 4 equals to 16, and then becomes r to the power 4 cosine of 4 theta plus I sine of 4 theta is equals to 16 cosine of n times 2 pi plus I sine n 2 pi. And because we just equated the right hand sides of equation 1 and 2, since we are saying z to the power 4 is equals to 16. So what we are having now there is this equation here. What you now go in and do is compare the left hand side and right hand side of this equation which is above. So outside the parentheses there, we see that there is an r to the power 4 on the left hand side. On the right hand side we have a 16. So by comparison we see that the r to the power 4 there is equal to 16, and then we solve for r, and then we get r is equal to 2. Inside the parentheses, we are having cosine of 4 theta on the left, then on the right, we are having cosine of n2 pi. So by comparison, we see that 4 theta is equal to n times 2 pi. And then you solve for the theta, then it will give us theta is equal to n times pi divided by 2. But earlier we said that z in polar form is z is equal to r multiplied by cosine of theta plus I sine of theta. But we have just found the values of r and theta there. on these ones here, we said r is equals to 2 and theta is equals to n times pi divided by 2. So if we substitute those values of r and theta into the z which is below there, we'll get that our z is equals to 2 times cosine of n pi divided by 2 plus I times sine n pi divided by 2, where the n there is 0, 1, 2, and so on, since cosine and sine are periodic. So that's the solution to the equation z to the power 4 is equals to 16.